Okay, we're on section 3.3, Go tutorial problem 1, and we have a problem here where we have to go all the way through and create the regression, or find the regression equation. So we have, first of all, something I want to point out. It says teaching the same history course for 100 times. So where does that 100 factor into this? Well, it actually doesn't. But why is it even there? I think what they're trying to get through is, in order to calculate an accurate correlation, we really do need a fairly decent sample size. And so they're trying to bring home the point that you really couldn't do these kind of predictions with any accuracy without a fairly large pool of data. So that's where that 100 factors in. And then we have the number of points, or sorry, the correlation between points before final and final as 0.8. So that's going to be our value R. And then we have the mean and standard deviation of the befores and the mean and standard deviation of after. So the first thing we need to really look at is what is our X and what is our Y here, and how do we determine that? So it says predict her final exam score from her pre-final total. So what we're looking, first of all, what are we trying to predict? We're trying to predict final exam score. Whatever we're trying to predict is going to be our Y variable, and the thing we're using to predict that will be our X variable. So final exams will be our Y, pre-final will be our X's. Now in this case, I've tried to chicken scratch it out in front beforehand. So this first formula we're using, and this is from your book around example 3.10. B1 is the slope of the regression line, R is the correlation coefficient, and these are the standard deviations. So we're taking B1 equals correlation coefficient times standard deviation of Y, which is our final exam standard deviation, and this is our pre-final. So when you plug those points in, 0.8 for the R, 8 for standard deviation Y, so on, you get 0.21333 repeating, which is, in case you're wondering what that symbol means, that 3 repeats. So we got our slope of the regression line, but we still need to find the intercept. So we know this equation, and what this equation is, it's Y, so it looks very much like the regression equation where we have the predicted Y equals B0 plus B1 times X, except it's replaced, the X and Y are replaced by the mean of X and the mean of Y. And why is that? Well, one thing we're guaranteed on our regression line, one point that we always know will be on there will be the average of the X's and the average of the Y's. So when we're talking about a linear regression, that's a guaranteed point, which is beautiful because it allows us, once we know either the slope or the intercept, it allows us to find the other one, assuming that, of course, we do know the means, which usually we do have that information available. So I'm rearranging this equation here, taking the slope times the X mean over to the other side to get the intercept all by itself, and then I'm just plugging in the mean of these final exams, mean of the pre-finals, and I get that the intercept for the regression line is 14.36. So now I can create that now that I have my slope and I have my intercept, and then I know that, was her name Julie? I'm not sure what her name was, but she had a 300 coming into the final, so I'm just plugging that into the X to get her predicted final score in the class. And again, that's not her actual, that's her predicted, and 78.26, I believe they wanted that rounded to the nearest whole percentage, which is why we get the 78 in there.